Alright, welcome. We're going to do 1.7, midpoint and distance in the coordinate plane. So make sure at the top of your page that you have this written down. Our objective is to find the midpoint of a segment and to find the distance between 2 points in the coordinate plane. So something that we're going to really need to know and be really good at, because we're going to be using this all throughout. So first thing, we're going to make sure that we have everything written down in this box right here. So our key concept right here, everything in that box. So the first thing is when we're trying to find the midpoint, the middle, on a number line, we're just taking the average of the 2 points. So we are just going to take, for instance, right here, we're going to add the 2 points together and then divide by 2. So it's like a test score. It's the same way we find average. If you got like a 90% on one and a 70% on the other one, in order to find the average, we add those two together and then divide it by 2. When we have it on a coordinate plane, we are doing the same thing. Just this time we are going to add the x's together and then divide by 2, and then add the y's together, divide by 2, in order to find the midpoint. Alright, last definition that we're going to write down is the distance formula. So make sure we have everything in that box written down. An important formula for us to know. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So we're going to need to make sure that we memorize that formula. How do we get the distance formula? We derive it from Pythagorean theorem. If you guys have remembered that from previous grades that you guys have covered. If you see right here that we basically make on this coordinate plane that we are making it into a right triangle and then finding the distance to one of the sides. So the reason that we square the points and then we take the square root is because our distance always needs to be positive. We can't have a negative distance. Alright, problem number 1 that we're going to write down. Make sure that you have problem number 1 written down. Is finding the midpoint. So it says that AB ends at -4 and 9. What is the midpoint? So we don't even need this little diagram over here in order to find it out. But remember, we take the average of the 2 points. So take the average, I'm taking -4 plus 9, and to take the average means that we're going to divide it by 2. So this -4 plus 9 is 5. 5 divided by 2 is going to give us the midpoint of 2.5. So if I were to put it on this number line right here, 2.5 would be somewhere about right here, which would be in the middle of those 2 points. Alright, next, problem number 2 that we're going to have. So make sure you write problem number 2 right here. This one we're trying to find an endpoint this time. So the problem gives us the midpoint, and it's at 2, -1, and it gives us one of the endpoints at -5, 7. So we have that one endpoint right there, and we have the midpoint right there. We're trying to figure out where is that other endpoint right there. So we remember though that when we have our midpoint right here is going to be, when we're going to take the average of the x's and the average of the y's right here. So we're going to have y1 plus y2 over 2. And so we're given the midpoint right here. So a midpoint we're going to put in. So let's put in -2, 1. That's our midpoint. And then we're going to put this in. So remember, this first one right here is going to be my x1, and the second one is going to be my y1. Sorry, y1 right there. Should be a 1. So where x1 is at, I'm going to put a, let's see if I can write it right here, a -5 plus x2 over 2, and I'm going to have y, no, I don't want y, I want to plug in the y point since I already know it. So I'm going to plug in right here my 7 plus y2 over 2. Alright, so now how do we find out what that point is right there? Well, we know that our midpoint right here, that we already have that this is our x and this is our y. So what we're going to do is we're going to set both of these. We're going to set this one equal to the x and set this one equal to the y and solve. So I'm running out of room, so I'm going to erase the y part right here, but just keep going down on your page in order to give yourself some room. So I'm going to erase a little bit over right here to give myself some room. So let's see if I can fit it right here, and I'll do it in a different color so you know. Let's do this in red right here. So I know that my x midpoint is -2, and we said that this right here was -5 plus x squared over 2. So we're trying to get this x2 all by itself. So I really want to get rid of this divided by 2 in the denominator. So how to do that? I'm going to multiply both sides by 2. And so this is going to give me -4 equals -5 plus x squared. So I'm going to add 5 to both sides, and then I'm running out of room. That's going to give me x squared equals 1. So I know right here, and I'll write it right up here for my final answer, I know that one of the endpoints has the x of 1 right there. So I need to find the y endpoint now. So I am going to erase this really quick to give myself some more room. Just keep working down on your page in order to make it nice and clean. And again, I will put this in red. So now let's find it for the y. So we said that the y was 1, the midpoint, and we said that it was 7 plus y2 over 2. So I'm going to do the same thing. I want to get rid of that denominator of 2, so I'm going to multiply both sides by 2. Multiply both sides by 2. And so this is going to give me 2 equals 7 plus y2. I am then going to subtract 7 to both sides. And this is going to give me -5 equals y2. So I know that my endpoint for the other one is 1, -5. So when I go to put that on there, I go over 1, down 1, 2, 3, 4, 5, and it should be about right here, which makes sense that it looks about right as far as the distance in between. Alright, and then our last problem, problem number 3 right here, says find the distance. So we have 2 points, and we're trying to find the distance, and it says round to the nearest, and I'll move this out of the way a little bit, round to the nearest 10th. Okay? So it's really important right now that we remember our formula for distance. So we're going to say that distance equals, it is the square root of, we're going to have x2 minus x1, and we're going to square that, and we're going to add it with y2 minus y1 and square it as well. And this is all underneath the square root. Alright, so now we just have to basically label and then plug it in and then solve. So when I'm labeling it, it doesn't really matter which one you label as long as you label them as far as you label it as far as having one of them be the x1 right here and this one be the y1. It really didn't matter whether you label this one or that one as long as you have them all in the right order. So this one, you have x1 and y1, and this you have x2 and you have y2. So now we're just going to plug these in and solve. So I have x2 right here is 4 minus -7 squared plus, and I have y2 is -3 minus 5 squared, and this is still underneath the square root. So I have 4 minus -7, so this is going to be 11 right here, 11 squared plus -5 minus, it was going to give me -8 squared. So again, I don't really care whether or not you use a calculator. So you can use a calculator if you don't know it, but 11 squared is 121. And then 8 squared is going to give us 64. So now on your calculator, if we add these two together, 121 plus 64 is going to be 185. And remember, we're taking the square root. I should have written square root on each of these. That's the step I was going, but the square root of 185. This isn't a square root, but when we put this into our calculator right here, we are going to get equals 13.601. We're going to round to the 10th, so 13.6. So really important in this one that we remember our formula, because all we have to do if we know the formula is just plug it in and then chug out the answer. All right. Thank you, guys.